This conference will now be recorded.
Okay, the question is, draw the movement diagram for the frame shown in the figure. Okay, this is not a portal frame. So that only the question they gave for the frame shown in figure. EI is constant for all the members. Use the slope deflection method for analysis. Okay, so in this frame, okay, there are three members in it. Okay, A to B, B to C, C to D. Okay, totally three members in this frame. Okay, so support A is fixed and support D is also fixed. Okay, the support A is a bottom support. Okay, but support D is the top support. Okay, the support D is at the top and member is at the bottom. But in member AB, the support is at the bottom. Okay, the fixed support is at the bottom and the member is at the top. Okay, and we are having a lateral load at point B, that is 30 kilonewton. The span length of all the members are 2 meter. Okay, span AB, BC, and CD all are 2 meters only. Okay, so what are all the unknowns? Okay, so first we have to check where the slope will occur. If the fixed end means slope will not occur, slope will be 0. Okay, in other points, other joints and all, the slope will occur, and this way is the next unknown. Okay, so support A is fixed one and support D is also fixed one. So the slope will not occur at those points at support A and support D. Then remaining joint B and joint C and all, the slope will occur. So theta B and theta C will come. Okay, so two unknowns, theta B and theta C. Okay, so these two unknowns is because of the slope. Okay, and third unknown is the sway. Okay, so in this frame, the sway will occur. Okay, because it is unsymmetrical and also it has a lateral load 30 kilonewton. Okay, so because of these reasons, the sway will occur. Okay, so third unknown is the delta. Okay, that is the lateral movement distance. This delta denotes the lateral movement distance. Okay, so the unknowns are theta B, theta C, delta. Okay, so what is the first step in slope deflection method? So calculation of fixed end moments. Okay, so solution. First step is calculation of fixed end moment. So the fixed end moment formula depends upon the loading conditions in the frame. So in span AB, BC, and CD and all, we don't have any loads. Okay, only one load we are having. That is also a joint only. So therefore, the fixed end moments will be 0. Okay, so since there is no span loading in any of the member, fixed end moment for all the members is 0. Okay, MFAB, MFBA, MFBC, MFCB, MFCD, MFDC, all are 0 only. Okay, since there is no load in the spans. Okay, so second step is calculation of slope deflection equations. Okay, so there are three members. Okay, three spans AB, BC, CD. Then how many slope deflection equations will occur? 6 slope deflection equations. Okay, each span has 2 equations. So for first, we'll calculate for span AB. So for span AB, MAB equal to, the formula is MFAB plus 2 EI by L into 2 theta A plus theta B plus 3 delta by L. Okay, so this is the formula. Here the delta denotes the sway, lateral movement of the frame. Okay, so MFAB value is 0. We know MFAB is 0. The fixed moments for all the spans, the value is 0. Okay, so 0 plus 2 EI by L. So L for all the span, the length is 2 meter only. So 2 EI by L is 2, 2 EI by 2 into 2 theta A. Okay, so theta A is 0. Support A is fixed, so slope will not occur at that point. So theta A is 0, 2 theta A plus theta B. Theta B will come. We have to calculate that. Okay, then minus. Okay, so here the in span AB, the support is at the bottom and the member moves towards right hand direction. Okay, you can see this in this figure. Okay, support is at the bottom and B moves in right hand direction. Okay, so B moves to B dash. So the amount of movement is delta. Okay, so the delta will be negative if the support, if the member moves right side means the delta will be negative. Okay, so due to lateral load, right or top support sinks. Okay, so always to the right. Okay, due to the lateral load, the span moves towards the right, so therefore the delta is negative. Okay, so in this case, the support is at the bottom. Okay, when we compare to the support, the span moves to the right. So the delta is negative. So minus 3 delta divided by 2. So the length is 2. Span AB length is 2 meter only. So 2. Okay. So since theta A is equal to 0, so 2 EI by 2 cancel EI. Okay, EI into theta B minus 3 by 2 1.5. So minus 1.5 delta. Okay, so this is equation number 1 for MAB. So MAB is equal to EI into theta B minus 1.5 delta. Okay, next MBA. Okay, right to left movement. MBA is equal to, the formula is MFBA plus 2 EI by L into theta A plus 2 theta B plus 3 delta by L. Okay, so this is the actual slow deflection formula. So MFBA value is 0, 0 plus 2EI by 2. Okay, so theta A is 0, so plus 2 theta B minus 3 delta by 2. Okay, since we are dealing with the same number, okay, that is span AB only, so delta is negative only, so minus 3 delta by 2. So 2 EI by 2, 2 cancel, EI will come, so EI into theta A is 0, so theta B is unknown, so 2 theta B minus 1.5 delta. Okay, so this is equation number 2. MBA equal to EI into 2 theta B minus 1.5 delta. Okay,
This conference will now be recorded.
so after calculating for the first span AB, next we can calculate for the second span BC. Okay, so this is for the second span BC. Okay, the slope deflection equation MBC is equal to M of BC plus 2 EI by L into 2 theta B plus theta C plus 3 delta by L. Okay, so M of BC value is 0. So 0 plus 2 EI by 2 into 2 theta B plus theta Z. Okay, so in this span BC, both the unknowns are unknown. Okay, but that is slopes theta B and theta C's are unknown. So both the values will come 2 theta B plus theta C. Here the delta value is 0. Okay, the span BC moves horizontally. Okay, there is no change in change of length in span BC. Okay, so therefore the delta value is 0. Okay, so the equation is 2EI by 2 cancel. So EI into 2 theta B plus theta C. Okay, so this is equation number 3. MBC is equal to EI into 2 theta B plus theta C. Next, in the same number, so BC, okay, the right to left mode, MCB equal to MFCB plus 2 EI by L into theta B plus 2 theta C plus 3 delta by L. Okay, here also theta B, theta C will come, delta is 0. Okay, M of CB value also 0. So 2 EI by 2 into theta B plus theta C. Okay, so the final equation is EI into theta B plus 2 theta C. Okay, so MCB, this is equation number 4. Okay, next, for the next span CD, okay, or DC. Okay, that is the support D is at the top. Okay, the member is at the bottom. So MCD. Okay, first we are taking left to right movement. Okay, MCD is equal to M of CD plus 2A by L into 2 theta C plus theta D plus 3 delta by L. Okay, so this is the actual slope deflection formula for MCD. Okay, MOCD value is 0, so plus 2EI by L. Here also the length of span CD is also 2 meters, so 2EI by 2 into 2 theta C plus theta D plus 3 delta by 2. Okay, here the delta value is positive. Okay, since the support is at the bottom, okay, when we compare to the support, okay, when we compare to the support D, the number is moving towards left side. Okay, the C is moving left side to the number D. Okay, so therefore the delta is positive. But in previous case, when we compare to the support A, the number is moving towards right side. Okay, so therefore the delta is negative. But In this case, when we compare to support D, the member is moving towards right. So therefore, the member is moving towards left when compared to support D. So therefore, the delta is positive. Okay, so plus 3 delta by 2. Okay, so EI into 2 theta C plus 1.5 delta. Okay, so this is equation number 5, MCD. Next, MDC. So MDC is equal to M of DC plus 2EI by L into theta C plus 2 theta D plus 3 delta by L. Okay. For same number CD only, no. So same, the delta is plus only. So 2EI by 2, M of DC value is 0. So 2EI by 2 into theta C. Theta D is 0. Okay. Support D is fixed, so slope will be 0 plus 3 delta by 2. So finally, the equation MDC is equal to EI into theta C plus 1.5 delta. Okay, this is equation number 6.
This conference will now be recorded.
Okay, the next step is joint equilibrium equations. Okay, so in this member, we are having 4 joints. Okay, that is joint A, joint B, joint C, joint D. Okay, joint A and joint D are fixed support, so movement will be there. Okay, we don't know that movement, so we have to calculate. Okay, joint B and joint C are intermediate support. Okay, so intermediate support, it has two members. So joint B is intermediate but has two members, that is AB and BC. So two moments will come at joint B, that is MBA and MBC. Okay, if we add these two moments, that is MBA plus MBC, we have to get 0. Then only joint B will be in equilibrium position. Similarly, a joint C also. Okay, so therefore the joint equilibrium equations at joint B and joint C are MBA plus MBC is equal to 0, MCB plus MCD is equal to 0. Okay, so two joint equilibrium equation. Okay, MBA plus MBC is equal to 0, MCB plus MCD equal to 0. And third equation is, okay, because of the sway. Okay, so because of the sway, summation H is equal to 0. Okay, summation H is equal to 0 means sum up of horizontal reaction. Okay, so that is the meaning. So here in this case, okay, so fixed support means three reactions will act. Okay, vertical horizontal movement. So we are solving summation H only. Okay, so HA plus this 30 and one more vertical reaction also will join D. Okay, we all these three reactions we have to get 0. Okay, so that is the meaning. Summation H is equal to 0. So that is the third equation. Okay, since we are having three unknowns, okay, theta B, theta C, and delta. Okay, three unknowns, but we'll have two joint equilibrium equation, and third equation is shear equation. Okay, that is summation H is equal to 0, HA plus HD plus 30 is equal to 0. Okay, we are assuming HA plus HD also in towards right hand direction only. Okay, 30 kilonewton is acting towards right side direction, and we know there is a horizontal reaction at A. Similarly, there is a horizontal reaction at D. Okay, we are naming HA and HD. We don't know which side it is acting, either right side direction or left side direction. We are assuming that HA is acting right side direction. Similarly, HD is also acting right side direction. Okay, so that only we are putting all these three values in plus. HA plus HD plus 30 is equal to 0. Okay, so three equation. First equation, MBA plus MBC is equal to 0. Second one, MCB plus MCD is equal to 0. And third one, HA plus HD plus 30 is equal to 0. So first, we are solving the first joint equilibrium equation, MBA plus MBC is equal to 0. We know MBA and MBC. Okay, MBA is equation number 2. MBC is equation number 3. Okay, this is MBC, EI into 2 theta B plus theta C. Okay, so we are substituting those equations. MBA EI into 2 theta B minus 1.5 delta plus MBC is EI into 2 theta B plus theta C is equal to 0. Okay, so on solving this, okay, we are getting an equation 4 theta B plus theta C minus 1.5 delta is equal to 0. Okay, and we are naming this equation as equation 1. Okay, And next we are solving the next joint equilibrium equation, that is MCB plus MCD equal to 0. Okay, we know the MCB equation and MCD equation. We are substituting in this, and on solving this, we are getting one more equation. Okay, theta B plus 4 theta C plus 1.5 delta is equal to 0. Okay, so this is equation number 2. Okay, so in those two equations, we are having three unknowns: theta B, theta C, delta. Okay, three unknowns. Since we are having two equations, okay, so far we have calculated two equations only by using two joint equilibrium equations. We are having three unknowns. So we are going for the third equation, that is shear equations also. Excuse me. Okay, next we are solving the third equations. Okay, that is HA plus HD plus 30. Okay, third equation, this one. HA plus HD plus 30 is equal to 0. Okay, so this horizontal reaction will act on the vertical members only. Okay, that is span AB and CD only. So this is for span AB. Okay, this particular diagram is for span AB. So bottom support is A and top support is B. Okay, uh, so we are assuming HA is acting towards right. Okay, and we are having moments. Okay, we are also assuming that both the moments will be in clockwise. Okay, MAB and MBA. Okay, since the support A is fixed support, movement will be there. Okay, so MAB, we are assuming MAB in clockwise. Similarly, join B's intermediate, so movement will be there, and we are assuming a clockwise movement MBA. Okay, similarly in CD also, a joint D is there is a fixed support, so we are assuming an horizontal force towards the right side, and we are also assuming the movements also in clockwise direction. Okay, 2 meter, 2 meter, the length of the both the spans. Okay, that is AB and CD, and we are resolving that. Okay, so 2HA is equal to MAB plus MBA. Okay, we are taking moment about point A or point B. Okay, that is the they did here. Okay, so taking moment about point A or point B, will get this equation. Okay, 2HA is equal to MAB plus MBA. Okay, on solving this, okay, we'll get an equation. Similarly, on solving the span CD also, okay, we'll get 2HD plus MCD plus MDZ is equal to 0. Okay, we'll get HA equation and HD equation. Okay, and after getting HA and HD, we are substituting in shear equation, that is HA plus HD plus 30 is equal to 0. Okay, this is equation for HA and this is for HD. We are substituting that in shear equation. HA plus HD plus is equal to plus 30 equal to 0. Okay, so on solving this also, we'll get one more equation. Okay, theta B minus theta C minus 2 delta is equal to minus 20 divided by EI. Okay, this is equation number 3.
This conference will now be recorded.
So after calculating the three equations, okay, equation number 2, 3, okay. So we have three equations with three unknowns, theta B, theta C, delta. So by using calculator or by manually, we can calculate the unknowns theta B, theta C, and delta. Okay, so delta is 20 by EI, theta C is equal to minus 10 by EI, and theta B equal to 10 by 8. Okay, so after calculating the unknowns, okay, theta B, theta C, delta, the next step is calculation of final moments. Okay, step number 4 is calculation of final moments. We are going to substitute the unknowns in the slope deflection equation, that is MAB. Okay, so MAB is equal to, we derived an equation for MAB. MAB is equal to EI into theta B minus 1.5 delta. Okay, so we are substituting theta B delta in MAB equations. Okay, after substituting theta B delta, we'll get the MAB value. Okay, so MAB is equal to minus 20 kilonewton meter. Similarly, MBA, MBC, MCB and all. So MBA minus 10, MBC plus 10, MCB minus 10, MCD plus 10 kilonewton meter, MDC is equal to 20 kilonewton meter. Okay, so after calculating the final movements, okay, the next step is uh, bending moment diagram only. Okay, so this is the member. Okay, AB, BC, and CD. So in AB, okay, so AB minus 20 anti-clockwise movement, and BA minus 10, that is also anti-clockwise. Okay, then BC plus 10, okay, clockwise movement, and MCB minus 10, so anti-clockwise movement. Then CD, okay, so CD plus 10, so clockwise movement. In CD, MCD is plus 10, so clockwise movement, and MDC is plus 20, that is also clockwise movement. Okay, so by using these values, we can draw the bending moment diagram. Okay, so this is the bending moment diagram. Okay, so AB is the vertical member. Okay, so the vertical member means we have to fix which side is the above the baseline and which side is the below the baseline. Okay, so AB, so this is the member AB. So left side of the span AB is the above the baseline, and right side of the span AB is the below the baseline. I'm fixing like that. Okay, left side of the span AB is the above the baseline, and right side of the span AB is the below the baseline. Okay, so normally left to right movements means, okay, MAB is left to right. Okay, left to right, anti negative value only above the baseline. Okay, so we are getting negative value only. We are getting MAB negative value only. Okay, MBA also negative value. So MAB minus 20 negative value. So we are putting above the baseline. I fixed the left side of the span AB as the above the baseline. So minus 20 is in the left side of the span AB. Okay, so this is minus 20. And MBA positive value only above the baseline. MBA is right to left. So MBA positive value above the baseline. But we are getting MBA as a minus 10. Okay, so below the baseline. We are considering the right side of the span AB as the below the baseline side. So this point, okay, so minus 10, and we are connecting those 2 points. Okay, next BC. So this is horizontal member only, so it is easy. Okay, so MBC is left to right, negative value above the baseline, positive value below the baseline. Okay, so when MBA is minus uh, 10 means on automatically MBC is plus 10. Okay, so MBC is left to right, positive value, so below the baseline. Okay, this value, this point. Then MCB, okay, right to left, positive value only above the baseline, but in this case also MCB also we are getting minus 10 only, so below the baseline, and we are connecting these 2 points. Okay, then MCD, span, next for span CD. Okay, MCD and MDC. Okay, here also we have to consider. Okay, I'm considering the left side. Okay, first we'll check the values. We are getting MCD plus 10 and MDC also plus value. Okay, so this is left MCD. Okay, MCD is left to right, MDC is right to left. Okay, so this is vertical member. I'm considering this left side of the span CD as the above the baseline, and right side of the span CD as the below the baseline. So MCD is left to right, negative value above the baseline. Okay, positive value below the baseline. So we are getting positive value only, plus 10. MCD has a plus 10 kilonewton meter. So below the baseline. Okay, we are marking a point 10 kilonewton meter. Then MDC is right to left. Okay, so right to left means positive value above the baseline, negative value below the baseline. So we are getting positive value only. MDC yes plus 20, so above the baseline, and we are connecting these 2 points. Okay, so that's it. This is the bending moment diagram.